All right, in this lesson, we're gonna be going over the DX7V plugin. We're gonna generally understand every section of it, how it relates to FM synthesis, and hopefully you guys can take this and bring it to your own sound design in your FM synthesis software or hardware. So to start, we're gonna be looking at the operator section, or essentially these are the oscillators of this FM synthesizer. So right here in the overview pane, you can see that we have OP1, OP2, OP3, OP4, OP5, and OP6. These are the 6 operators that we have to work with to actually generate sound. You can think of these operators as oscillators on a subtractive synth, but these operators can only be sine waves. And how we use these operators is we have some that create sound and others that modulate those sound sources. Now, the different ways that we can organize these are given to us by this algorithm pane right here. If you see this square with the number on top and the little diagram, we can scroll through this and we have 32 different algorithms with different orientations of these operators to be organized. This really gives different timbre changes and creates sounds from classic synth sounds to string sounds to metallic sounds to all different types of stuff. Now, to really understand which algorithm lends to each sound really takes you working with each one and understanding how each sounds. Now, the classic DX7 synthesizer had 32 algorithms as well. These 32 algorithms they felt could really grab all the types of sounds that you would want to build. And by manipulating these different algorithms with different operators and different modulation sources, this would really give you a whole wide variety of anything you could imagine. Okay, so like I said, right here we have our operators. If we go here and we set the synthesizer to default, which basically just takes the synth and brings it to the bass setup. So right now we have defaulted the synthesizer. Right now we just have one operator that's being fed into the rest of the synthesizer, into the filter section and the envelope section, just like you would have in a subtractive synthesizer. But this, like I had said, we use operators instead of oscillators. So this one operator, all it's doing is producing a sine wave at whatever frequency we play. Now, if we have another operator that we bring in, and if you see here, what I'm doing is I'm increasing the gain of the operator. Now, if you look, we're on algorithm 1. So if we turn off all these other operators, 3, 4, 5, and 6, all we have is 1 and 2. And what you can see is we have operator 1 that's producing the sound and operator 2 that's modulating this sine wave to create a different timbre change. So based on the different ratios we have between the operators and the different amplitudes, we have different timbre changes and different volumes of that timbre change. Let's hear as we sweep the volume of operator 2 up at a 1-to-1 ratio. As you can hear, it's the same tone, but the timbre is changing. And we are really only using 2 sine waves to do this. So as you can see, if we add more operators and more sine waves, the possibilities are really endless. The way you can really organize these operators is based on the algorithms, like I had stated before. And you can go through these different algorithms to hear how the different ones will sound. Right now, you're only hearing the same sound because I only have 1 and 2 enabled. But if we start bringing in the other operators, different timbre changes. And you can really get really creative with this. You can turn sine waves into square waves, sine waves into saw waves, sine waves into organ sounding stuff, sine waves into strings. It's really, really incredible the things you can do with FM. Next, we're going to talk about filters and envelopes for the operators and for the entire synthesizer. So each of these operators can, one, have their own envelope and their own filter. By changing the envelope for the operator in this FM synth, we can create when that operator is actually modulating the source or it is creating sound, being the source itself. So from this, we can take a sound that may be stagnant and have different parts and different timbre changes coming at different times to create a really dynamic sound just in the operator section without even going into the other parts of the synthesizer. Now that we've been over the basis of the software FM synthesizer, the DX7V, let's get into the more general types of features it has that other synthesizers will have as well. Things like general envelopes for the entire sound, a modulation section where you can send low frequency oscillators to do normal types of modulation like vibrato, tremolo, things like that, and an effects section, which you can really then add things like reverb, chorus, delay to enhance the sound from its basic thing that you've built in the operator section, envelopes, and modulation, and take it to a whole nother level. If you're interested in this plugin and learning a lot more about how this works and the inner workings of it from this basic overview I just gave, please check out my other course at soundcollective.com on advanced FM synthesis and wavetable synthesis, where we'll really get into the nitty-gritty of how the operators work, how the different ratios work, what they're doing, and how you can really decide certain timbre changes based on your ear. So this concludes the overview of FM synthesis, and next we'll talk about wavetable synthesis, a whole other type of sound generation. After that, we'll bring those together, and we'll talk about how FM and wavetable synthesis can be used in your sound design and to enhance your productions and compositions.